Hello and good day, everyone. Welcome back to my YouTube channel. This is Sir Marcy, and we are now on our part 4 of Module 2, Week 6. And the title of our lesson for today is all about the conjugates and division of radicals. If you're new to my channel, please consider subscribing and hit the notification bell so you'll be updated with my latest videos. Let's try to recall first how to find the product of two binomials. There are many ways on how you can find the product of binomials. You can apply FOIL method, can apply squaring a binomial, or difference of squares, and many more. In our problem number 1, I'm going to apply using FOIL method. Do you still remember FOIL method? That is first term, outer term, inner term, and last term. So let's try to solve for number 1. Let's say we're going to find the product of x minus 1 times x plus 1. So first, we're going to multiply the first term to the first term of the other binomial. So x times x, the answer is x squared. Next, x times positive 1, the answer is positive 1x or simply positive x. Next, we multiply negative 1 times x, the answer is negative 1x or simply negative x. Lastly, we have negative 1 times positive 1, the answer is negative 1. Then we're going to add, so bring down x squared, and notice that positive x plus negative x produces 0 pair. So we just cancel this out because that is 0. Then bring down negative 1. And here is now the product of x minus 1 times x plus 1. Let's try to apply difference of squares in problem number 2. In this case, in order for us to get the product, we simply get the square of the first term minus the square of the second term. Remember, we can only apply that if the second term are of different signs. That is why this is the product of the sum and difference of two squares. Now, again, we're going to square only the first term. So we have 3x raised to the second power minus 2 raised to the second power. So 3x times 3x, the product is 9x squared minus 2 times 2 or 2 squared, that is 4. And this is now our answer. Now let's try to apply this in our last example. We're going to get the product of the quantity of 2 plus square root of 3 times the quantity of 2 minus square root of 3. So again, we are going to square the first term. So that's 2 squared minus the square of our second term, which is square root of 3. So 2 times 2, that is 4, minus square root of 3 times square root of 3 is square root of 9. And remember that square root of 9 is a perfect square. So we have 4 minus 3. Then we can simplify. 4 minus 3, our answer is 1. In our last example, I ended up with all whole numbers. Okay, technically they are integers, but the point is that the terms do not include any radicals. I multiplied two radical binomials together and got an answer that contained no radicals. You may also have noticed that the two binomials were the same, except for the sign in the middle. One had a plus and the other had a minus. This pair of factors, with the second factor differing only in the one sign in the middle, is very important. In fact, this same except for the sign in the middle second factor has its own name. We called it conjugates. Conjugates are the sum and difference of the same two terms. For example, we have 5 plus square root of 3 and 5 minus square root of 3. When you multiply the conjugates, no radicals are left. The middle term cancels out like in difference of two squares. Remember, to create the conjugate, all you do is flip the sign in the middle and everything remains the same. So for example, what is the conjugate of 1 plus square root of 2? So we will just flip the positive sign. So The opposite of positive sign is negative. The answer here now is 1 minus square root of 2. The same goes with example number 2. What is the conjugate of square root of 7 minus 5 square root of 6? Our answer here is square root of 7 plus 5 square root of 6. And lastly, what is the conjugate of negative 7 square root of 3 plus 2? The answer here is negative 7 square root of 3 minus 2. So these are the conjugates. Again, to create a conjugate, all you need to do is flip the sign in the middle and everything else remains the same. Now let's try to rationalize letter A, 2 all over 3 plus square root of 5. If you still remember in our previous lesson, we must free the denominator from radicals. So if you're going to examine, we have square root of 5 in the radical sign. So we have to get rid of that. So to do that, what we need to do is to multiply it by its conjugates. So the conjugate again of 3 plus square root of 5 is 3 minus square root of 5. So we will multiply it by its conjugate. So let's try to multiply 2 times 3, that is 6, minus 2 times negative square root of 5, the answer is 2 square root of 5. All over, we're going to get the square of the first term. So that's 3 times 3. We have 9 minus square root of 5 times square root of 5. That is square root of 25. Then we simplify. We now have 6 minus 2 square root of 5 all over 9 minus. The square root of 5 is, square root of 25 is 5. Then we simplify again. This is now 6 minus 2 square root of 5 all over 9 minus 5 is 4. Notice that 6, 2, and 4 are all divisible by 2. So we can simplify our answer here. The answer here would be 3 minus square root of 5 all over 2. And notice that our denominator now is free from radicals. Therefore, this is now the simplest form of 2 all over 3 plus square root of 5. Okay, let's try to solve letter B. Remember, we have to get rid of radicals in the denominator. So we're going to multiply this both sides by the conjugate of square root of 3 plus square root of 2. Again, the conjugate of square root of 3 plus square root of 2 is square root of 3 minus square root of 2. So we multiply both sides by the conjugates. Next, we multiply square root of 5 times square root of 3. The answer is square root of 15. Minus square root of 5 times square root of 2. That is square root of 10. All over. Since these are conjugates, we multiply the first term to the first term of the other binomial. We have square root of 3 times square root of 3. That's square root of 9. And square root of 2 times square root of 2, we have square root of 4. So minus square root of 4. Then we simplify. We have square root of 15 minus square root of 10 all over. Square root of 9 is 3 minus square root of 4 is 2. Then we have now square root of 15 minus square root of 10 all over. 3 minus 2 is 1. Then when we divide square root of 15 minus square root of 10 by 1, the answer here is square root of 15 minus square root of 10. So again, this is now our answer. And for our last example, let's say we're going to rationalize square root of b all over 1 minus square root of b. Again, we need to free our denominator from radicals. So we get or we multiply again this by its conjugate. So the conjugate of 1 minus square root of b is 1 plus square root of b. Then we multiply. We have now square root of b times 1. That is square root of b plus square root of b times square root of b, that is square root of b squared all over. So these are conjugates. So multiply the first term to the first term of the other binomial. 1 times 1 is 1 minus square root of b times square root of b. That is square root of b squared. Remember our property last time? If the index and the exponent are the same, we can cancel them out and the answer here is only a. So here, let's try to find um, those radicals that we can simplify. So we have square root of b here plus, remember, the index and the power are the same, so we can cancel out. So that's only b all over 1 minus the same with this one, that is 1 minus b. And this is now our answer. Remember, radicals are in its simplest form if the denominator is free from radicals. So this is our final answer. That's all for now. I hope you learned something new again, and I hope to see you soon. Goodbye.